How would you go about solving these integrals? Probably what we would do is do some integration by part or use some tricky trigonometry relationship between cosine and sine and try to do the math, right? What if I tell you that I have a trick that can make these integrals look like a piece of cake? Stick to the end of this video to find out how we do that. So before doing that, let's compute our integral here. If we introduce t equal cosine of x, then we have dt equal minus sine of x dx. So my integral becomes the integral of t to the power of 8 minus dt, and that's, if you do the math, you get 1 minus over 9 cosine to the power of 9x. That's easy, right? So what if we take this new integral here, which is cosine to the power of 3 divided by sine to the power of 4? How would you do that? I will introduce t equal sine of x, and then dt equal cosine of x dx. Now my new integral becomes the integral of cosine to the power of 2x divided by t to the power of 4 dt. Use the relationship cosine to the power of 2 plus sine to the power of 2 equal 1. We get a new integral, which is 1 minus t to the power of 2 divided by t to the power of 4 dt. And now I let you do the math and you find this final formula, all right? So the question that you might ask yourself is, how do I choose which variable to use? Is it cosine, sine? Is there anything else, right? So the trick that I will show you is called Bioch rule. So what does that mean? So if your function is a fraction of sine x cosine of x, and you are asked to integrate that function, what would you do is introduce a new function omega of x equal f of x dx. So if you have omega of minus x equal omega of x, then you use t equal cosine of x. And if you have omega pi minus x equal omega of x, you use t equal sine of x. If you have omega of pi plus x equal omega of x, then you use t equal tangent of x. If you have two of those three rules, then you use, in this case, t equal cosine of 2x. What if you have none of those rules? Then you use, in this case, t equal tangent of x over 2. So apply those rules to the remaining integrals and let me know in the comment section. If you like the video, please comment, share it with your friends, subscribe to my channel to help me grow. Thank you. Bye.